Alright guys, welcome to my YouTube channel. This is the HHG-ZM channel presenting webline, passplus webline education. Now in this video guys, I am going to talk you through place value concepts that you might need to use during GCSE mathematics exam. Right, we're going to go through all the concepts that are necessary for you to be able to tackle the questions in an exam, and then afterwards I'll talk you through some examples, specific examples that are taken from various past papers, just to equip you with the knowledge that you might need. Okay, now guys, let us dive into the concepts. Right guys, now let us get started by looking at place value in more details. Right, now this is what we'll be looking at today. We'll be looking at place value. We'll be looking at writing numbers in digits from words and vice versa. We'll be rounding off numbers. I will show you how to calculate and then use estimation, and you will also be shown how to find the number of significant figures. Okay, right, then I'll also show you the fraction wall and how you can use it to compare a mixture of numbers. Like for example, if you're given decimals, you're given fractions, or you're given fractions, you can use the fraction wall to actually compare the numbers. Now the learning outcomes guys, from this lesson you should be able to compare numbers, round off numbers and estimate numbers, round off numbers to the required significant figures, and also write numbers from words and vice versa. Right, now with this knowledge guys, with this knowledge you will be able to solve the following questions in an exam. Okay, you'll be able to round off the following numbers to the nearest whole number. Right, you'll be able to find the number of significant figures of the given numbers. You'll be able to write numbers from words into digits. You will be able to actually arrange numbers in a certain order. In this question is asking you to arrange the numbers in an ascending order. The word ascending means starting from the smallest, ending with the biggest. Right, now as you can see there in question 4, the first one, that's 4a, gives you all the decimals, right? Then the second one gives you a mixture of numbers. The third one just gives you all the fractions. Okay, now let us dive into what the place value is. Place value table. Now the place value concept, right, is all about finding out the value that the digit occupies in a number, because a number is essentially made up of different digits. Right, now digit is simply a numerical symbol which can be 0, 1, 2, 3, 4, A, B, etc. Right, now one or more number of digits can actually make the whole number. Right, now this is an example of a place value table there that you can see. Right, from here where you see the dots here, these are the decimal points. Right, on our right hand side there you've got the decimal numbers. You start with the 10th, 100th and the 1000th, going that way. Right, now you can notice that the th there, right, that is what will tell you to say these are all decimal numbers going to the right. Now going towards the left side there, you've got the ones, you've got the tens, you've got the hundreds, you've got the thousands, and you've got the 10,000s. Right, now from this place value table you can notice clearly that 1, right, is under the ones column. This alone tells you what the value of that 1 is. Right, this 1 can be 0, it can be 1, it can be any number in there up to 9. right? You can never enter 2 digits under one column of the place value table, right? So by comparison, 1 here is actually greater than 3 because 3 is the 10th, right? When we do fractions later on in the series, you understand what a 10th means, but I'm going to tell you anyway. A 10th simply means 3 out of 10. This is what it means. 100th here, 7 here would represent 7 out of 100. 4 here, it is under thousandths, it represents 4 out of 1,000. So you can see that these numbers this side are actually smaller, but these ones going this side are bigger. Now I'll show you later on when we look at examples in a more detailed way of how the place value table actually becomes useful in finding solutions to exam questions. Okay, right, now let's look at the fraction wall. Right, now the fraction wall, like I said in the introduction, it's simply a chart, right, that you can make on your own, or you can use standardized one, used to compare the size of fractions. Now this chart actually gives an idea of the true meaning of what a fraction is. Okay, if you look at the first bar there, it's a complete bar, right? This bar is 1 bar. Now if you take the same bar and divide it in 2 parts, you'll have 2 parts that are equal, right? This part here is 1 out of 2. This one is also 1 out of 2. In mathematics we call it half, and that is half. Now the same bar, if you divide it into 3 parts, you'll have 3 equal parts, each one of them representing a third. This is 1 out of 3 parts, 1 out of 3 parts, 1 out of 3 parts. Okay, if you go down there, the same bar, right, divided into 4 equal parts, each part will represent a quarter and a quarter and a quarter and a quarter. The last one is the same bar, same size, divided into 5 parts. Each part will represent a fifth, that's a fifth, that's a fifth, that's a fifth, and that's a fifth. Right, now from the size of these portions here, you can actually tell that 1 is actually greater than half. This is what it says here. 1 is greater than half. It means 1 is greater than half. On this one here, if you compare half with a quarter, you can actually clearly see that all of this here compared to that, right, half is actually greater than a quarter. Now if you compare a third and a quarter, you can actually see from the size of a third and the size of a quarter that a third is greater than a quarter, right, and so on. Now sometimes you may be given questions, right, that have greater than 1 numerators, for example. You see from this one here, right, which I will explain later in details, if you add this one and that one, you've got 2 out of 2. 2 out of 2 is simply equal to 1. Okay, now my explanation right now might not be clear until I get to the actual example. That's when you understand what I mean by that. Now if you are trying to compare, like for example 2 thirds, this third and that third put together, they form 2 thirds. Now 2 thirds clearly would be greater than half. Okay, but if you look at half and two quarters, this will be 2 quarters, right? 2 quarters compared to half, they're simply the same. 2 quarters from there to there, and half is from there to there. They are simply equal. This will become very clear actually when you start looking at simplifying fractions later on in the series. Okay, now if you look at a third there, the third starts from there, ends there. Now compare that third with 2/5. 2/5. This one and that one combined, they form 2/5, which will be 2 out of 5. Okay, now 2/5 is clearly greater than a third. Okay, now that will become clearer when we look at the use of a fraction wall and how we can use it to solve exam questions. Now let's look at another important concept, Right, that is rounding off. Rounding off means making a number simpler by making its value intact or closer to the next number. Now, estimation uses rounding off of numbers. When you are told to estimate something, it means you are using the rounding off concept. Right. Now, as the rule of thumb, when you are actually calculating something, you wait until you find the final answer before you can round off. Because doing so before you reach the final answer might actually cause a lot of errors. Okay, unless you are told otherwise, you are only supposed to round off when you finish finding the final answer. Okay, now to round off, guys, you have this scale here to show you exactly what rounding off is all about. If you look at these two numbers here, you've got 6.4 right there, and you've got 6.5. Now, if you were to ask yourself, which one of these two numbers is actually closer to 7? The number closer to 7 clearly is 6.5. And 6.4 is a bit far off from there. Now, if you are told to round off these two numbers, this one can be rounded off to 7 by simply adding 1 to 6 and ignoring the 5. Now, whenever you are rounding off numbers, right, you have to look at the number immediate to the right of the target number. In this case, if you look at 6.5, our target digit is 6. And the number, or the digit, not the number, the digit immediate to the right is 5. So 5 and above, if you've got a digit which is 5 and above immediate to the right of the target digit, then you are allowed to round up. Rounding up means adding 1 to the target digit, and then depending on the place values of the number that you are dealing with there. In this one, since we've got a decimal point there, we can simply ignore that one and add 1 to that to make it 7. Okay, whereas in this case 6.4 can be rounded off to the nearest 6 because it's actually closer to 6. So for any digit, right, immediate to the right of the target digit, this is the target digit here, right, this is our target digit, this is the digit immediate to the right of our target digit. If this digit, which is immediate to the right of our target digit, is less than 5, then we have to round down. By that I mean we simply ignore the 4 and leave this number to be equivalent to 6. This is what I've done here. If you check, 5.5 is equivalent to 6, or is close to 6, or is roughly equal to 6. Okay, why? Because this is our target, this is our target digit, and this is the digit immediately to the right of our target digit. This is 5 and more we round up. So what we will do is we'll simply add 1 to that one to make it 6. But in this case here, because our digit immediate to the right of our target digit is less than 5, we will simply round down. Rounding down means leaving the digit as it is, and simply we get rid of that. Okay, I hope that is clear. It will become clear when we look at more examples, guys. Okay, right, now this is a simple diagram to show you, right, that rounding up starts from 5 and above, and rounding down, anything less than 5 you round down. Okay, now let's look at significant figures. Now, significant figures are digits that are important for accuracy's sake. Whenever you're making calculations, you want to as accurate as possible, you have to consider the number of significant figures. There will be questions that will be asking you to actually make an estimation according to the number of required significant figures. We will look at all those questions later on. Okay, now from this example, right, I've got these numbers with digits in different colors, right? All the numbers here. The first one has got digits in blue and digits in black. Now the digits in blue simply represent the non-significant figures. This is the key here to show you. All those in blue are non-significant figures. So it means when you're trying to find the number of significant figures, you don't have to consider these ones. In this example, this number only has 4 significant figures. These are the digits in black. So 1, 2, 3, 4. The second one has 2 significant figures because this one is non-significant and this one is non-significant. Right. This one here has 3 significant figures. Right. Now watch very carefully. Look at the difference between this one and that one. This 0 comes after the decimal point. Therefore it comes after the decimal point and after a non-zero number. So it is significant. So in this case we've got 1, 2, 3 significant figures. This one is not significant. This number here has 1, 2, 3, 4, 5 significant figures. This one here is not significant. Now, a simple rule here, right, can be made. One rule is all preceding zeros, that is all zeros in front of a non-zero number, are not significant. That's number one. These are not significant. They're all preceding, means they come before a non-zero number. These are all preceding digits, preceding zeros, I mean. Right? They are not significant. Now, trailing zeros, like this one here, it's a trailing zero. It's at the tail, it's at the back. It is not significant as well. Right? Now, notice the difference between this 0 and that 0. This is not a trailing 0. This is a 0 after the decimal point, right? Which is after a non-zero number. That's what makes it significant. Okay? In this case, these two, even if that 0 is after the decimal point, but because before the decimal point there is a 0 there, this 0 also is non-significant. I mean, not significant, is non-significant. If there was a number here before the decimal point, that 0 would have been significant. This is what is happening here. Compare this 0 and that 0. Right? With this 0, before this decimal point, there is a number. So that's what makes that 0 significant. But here, there is no non-zero digit, so therefore this one is not significant. So you need to practice more on this because this is one of the concepts that can be tricky in an exam. Right? But the more you practice, the better you become in mathematics. Mathematics is actually a practicing subject. So you make sure you give yourself at least 30 to 1 hour every day practicing mathematics. Right? They say practice makes perfect. In mathematics, that is very, very true. Right, guys, now that we've looked at the concepts under place value, right, it's time for us to it's time for me to now show you how you can actually solve some of the problems by giving you specific examples, right, that are drawn from various papers. Right, now let's get started, guys. Right, now guys, we are going to look at the examples after going through the concepts. Right, we're going to use those concepts actually to solve actual exam questions, right, and see how we can do a good job at solving the questions. Okay? Right. Just before we start, I just wanted to explain to you a certain concept to do with the fraction wall. Right. Now, fraction war, like I was saying, I went through all of them to explain, right, the differences and how you can use it to actually compare fractions. Now, if you take two of these, 2/3, that 2/3 and that 2/3, right, what you're going to have is a situation like that. So 2/3 means that third and that third, they give you what? 2/3. Okay? Now 2/3 is actually greater than 2/3 is actually greater than half. Check the size of that and check the size of that. If you look at the last one as well, if we add this one and that one and that one, if we add this fifth to that fifth and that fifth, we'll have 1/5 plus another fifth. What you have is 3/5. Is that fifth, that fifth, that fifth. So when you are adding fractions, as long as the denominators are the same, right, you simply add the numerators and retain the same denominator. This is what I did in the first place there, right? Denominator is 3, denominator is 3. You simply add the numerators. 1 plus 1 gives us 2. Then you retain the denominator to give us 2/3. Right. Now, this one, this fifth, added to that fifth and added to that fifth, you've got 3/5. Now, if you compare 3/5 to half, straight away you can see the size of this from there to there and the size of this from there to there. That 3/5 is actually greater than half. So roughly this is how you can actually make sense of the fraction war to compare fractions. Okay. Right, now let us go through the examples, guys, in details, right? Now, these are some of the questions that you might come across in an exam. Okay? I extracted these ones from a couple of past papers. Right? Now, the first question there reads, round off the following numbers to the nearest place value in brackets. Right? And this one is actually 3 marks because each one is just a mark. Right? Now, the first one there is asking us to round off 8.2 to the nearest whole number. So we look at our target digit, which is 8, and the digit immediate to the right of our target digit is 2, which is less than 5. So in this case, we're simply going to round down. Our answer will be 8. We simply ignore that, right? Because we simply need a whole number, right? Number 2, right? We are asked to round off 56 to the nearest 10. Now, 10 represents 2 digits there. Okay? So our target digit is this one. That's where the 10 is. And this one is our 1s. 10, so we target our 10. So that's our 1, that's our 10s. If you place this in a place value table, this is what it will give you. Right, it's simpler doing it like this instead of having to draw the place value table. Right, now this is our target digit. It's under the 10 column. Now the value, or I mean the digit immediate, the value of the digit immediate to our right is actually 6, which is more than 5. Right, now because that is more than 5, because that is more than 5, we are allowed to round up. So when we round up, we simply add 1 to 5 to make it 6. Then because this is a double digit number, right, we've added 1 to 5 to make it 6. So this 0, I mean this 6 here is simply crossed out and replaced with a 0 to make it 60. And if you were to use a scale, right, for example, if you're to use a scale, right, you have 60 here and you have 50 here, right, you have 55 there and you have 56 there. You can clearly see that 56 is actually close to 60, right, than 55. So when you're trying to round up, you can simply roughly estimate 56 to be close to to 60. Okay. Number 3, right? We are to round off 95 to the nearest 100. Now, that is a 1, that's a 10, and that's a 100. Now we can see that under the 100 column we've got nothing. So we can replace that void using a 0. Right, just for us to see clearly what is going on. Okay? Now in this case, because our place value digit is 100, that one there, this will be our target value. This will be our target digit, not value. So 0 is our target digit, and the value of the digit immediate to the right of our target digit is 9. And 9 is above 5, or it's more than 5. Therefore, we are allowed to do what? To round up. So when we round up, we simply add 1 to 0, which gives us what? 1. Because it says nearest 100, we must retain the value of the number, right? So we replace this 9 with a 0 and the other 5 with a 0. So 95 is clearly close to 100. Then number 2, guys, find the significant numbers of the following numbers. Number 1, there's only 2 significant figures here, because all the zeros, the trailing zeros, these are trailing zeros after the numbers, they are not significant. If you go back to the rounding off concept there, it makes it very clear. Okay, this one here has 1, 2, 3, that is 3 significant figures, because this preceding 0 is not significant, but this 0 after the decimal point, which is after a non-zero number, that is significant. So we have 1, 2, 3 significant numbers. Here we've got 1, 2, 3, 4 significant figures. These 2 are trailing zeros, right? This 0 is not significant because it's coming after the decimal point, which comes after a non-zero number, right? This one we have 1, 2, 3, 4, 5. This one has 5 significant figures in total. Right, now let us move on to the next question, guys. Okay. Yeah. Write the number 13,521 in digits. Okay. So this is the one where you have to draw a place value table. It's very easy. When you've done a lot of these things, you can simply write it away anyway. It's very simple. But for clarity's sake, I'm going to do a place value table, right? Okay. 13, 21. So 1 will be there. That will be a 2. And 5 will be under the 100. That's 500 there. And then there will be 13,000. So there will be 3 and a 1. Therefore that is 1, 3, 5, 2, 1. That leaves us 13,521. Okay. Practice more of these questions, the better you become at it. Right, now write down the following numbers in ascending order. In this case, we have to compare the size of these numbers, right? We need to find the smallest number. That's what we shall write first. Now, if you look at these numbers, right, they've all got zeros before their decimal points. So we are not going to use the zeros in front to compare them. So we move next to the numbers after the decimal point, right? We start comparing these ones after the decimal point. Okay. Now, if you compare the numbers immediately after the decimal point, you'll see which number is actually bigger. Already from what we can see there, 0.6 is actually the biggest of them all, and the smallest of them all is 0.09, because the value of the digit after the decimal point is actually 0, which is less than all of these. then followed by 0.0201, followed by 0.51. Okay, so the smallest number is 0.09, the biggest number is 0.6. Let us look at the next one. Okay, now the next one is a little bit tricky, right? Because it has got mixed numbers. Numbers are in different formats. You've got the percentage there, you've got the two fractions, and you've got the decimal. So the best approach you are to use when you're trying to compare these numbers and arrange them in a certain order, either ascending or descending. In this case, they're asking us to arrange them in ascending order, which means we must find out which one is the smallest and which one is the biggest, and then the rest that follow, fill them in. So what I would do in this case is to convert all these numbers into the same format, right? In this case, I'm going to choose percentage. Okay, I'll simply convert all of them to percentages, right? So we've got 50% there, which is already done for us. Then a third converted into a percent, you simply have to multiply it by 100, okay, which will give us 100 times 1 will give us 100 divided by 3. This will be 3.3%. Okay, you understand later on when we look at fraction of a number and dividing and all those, how to convert a fraction into a percentage later in the series, right? And then a decimal, that is 0.6 there. Also, to convert a decimal into a percentage, you simply times that by 100, and that is going to give us 60%. 60%, because when you're multiplying by a number which is a multiple of 10, like this one, 100 is a multiple of 10. You understand what multiples are later in the series. It's got 2 zeros there. The fact that it's got 2 zeros, 100 has got 2 zeros, allows us to move this decimal point, right? Move the decimal point to the right in 2 steps, like that. So we'll have the decimal point moved to here and there. Now this place here, this void there, you simply put a 0. That's how we get the 60. Right. Now this is just an algorithm. It's just a way of making it easier for you to understand. Right. When you look at fractions, it will become clearer how 0.6 times 100 becomes 60. Okay. At this stage, this is enough. Now 4/5. Okay, you times that by 100 as well to convert it into a percentage. This will give us 400, because 4 times 100 is 400, divided by 5. When you divide 400 by 5, the answer is 80, which is 80%. Now that we've converted all the numbers into the same format, clearly you can see that the biggest is 80, right? The biggest is 80. Right, oh, made a mistake here. The biggest is 80, guys. Right, write it there. Right, followed by 60, followed by 50, and then the smallest is 33.3%. Now the final answer, guys, very important this is, the final answer should actually be written in the format in which the question has given the numbers in. So we have to follow the same format as in the question. We know 33 there represents a third, so we'll write a third there. 50 is given as 50%, that's alright. Then 50 is followed by 60. 60% is actually 0.6, comma, and 80% is actually 4/5. Okay, some markers will not mind. You can lose a mark anyway, but some markers will be lenient with you. They'll give you the full marks because they will they will understand that you know what you're doing. Okay, now the last one, guys, this is where the use of a fraction wall can actually become useful, right? If you might want to use the fraction wall, you can use it actually to compare the fractions. But now you need to have how many bars? 8 bars going down, right? Which can take you a bit of some time to draw and perfect, right? So instead of having to draw the fractional wall, you can simply choose a format in which to present the number so that you can see clearly. Fractions as they are right now, they're very difficult for you to actually compare. So what I would do in this case is I would convert these into a simpler format which will make it easier for me to compare. I can either convert them into fractions, into decimal numbers or percentages. I've already shown you how you can convert them into percentage format, right? So this time I'm going to use the decimal format. So you convert all these into decimals, right? In that way it will be a lot easier for you to compare them. Now we can start with the first one, 2/3, right? 2/3, this simply means 2 divided by 3. So if you remember your long division, we can use long division there, right? Where the dividend is actually 2 and the divisor is 3. Then we divide. How many times does 3 go into 2? Or how many 3's do we have in 2? 0. We put a decimal point. Because we've done that, we are now allowed to add a 0 to the dividend. So we divide 20 by 3, right? We divide 20 by 3. How many 3's are in 20? We know 3 times 6 is actually 18, right? And the remainder is 2. Okay? At this point you can add a 0 again. After you've added the first 0, after putting the decimal point, you're allowed to add zeros all the way. So we add a 0 this one to 2 to make it 20, and then we continue dividing. How many 3's are in 20 here? It's also 6. So you find that this one will give you a recurring decimal to be 6.66. So approximately we'll have that one at 6.7, right? To the nearest 2 decimal places. Nearest 2 decimal places. That will be 67. Then we go on to 5/8, right? 5/8 converted into a decimal. We use the same method. Okay? 5 is the dividend. That one is the divisor. How many 8's are there in 5? There is none. We put a decimal point. Then we are allowed to add a 0 there. How many 8's are in 50? Right. Simple arithmetic. We know 8 times 8 is actually 64. No. So if we take out 1/8 from 64, we end up with 56, which is 2 more. If we take out another 8 there, we end up with 48. So we've taken out 2 8's, which gives us 6 8's, right? 6 times 8 is 48. You're remaining with 2. You add a 0 there. You've got 2. 2 times 8 is 16. You take away, you've got 4. You add a 0 there. Then you divide 40 by 8, you get 5. So this one here is equal to 0.625. Okay? Or we can leave them to 2 decimal places. We'll round this one off to 0.63. Okay? Round that one off to 0.63 straight away. That's okay. Then we go on to 2/7. we're going to do the same. That is 7, that is 2. So 2 divided by 7, it is not, to put a decimal point, put a 0. Then 7 into 20, it goes in 2 times. 2 times 7 gives us 14. When we subtract 14 from 20, we get 6. We're allowed to add a 0 there. Now, how many 7s are there in 60? 7 times 7 is actually 49. If we add a 7 there, we get 56. So that means there are how many? These are 7 7s plus this one, they give us 8. So it's 8. 8 times 7, it is 56. Then you subtract there, you have 4. Okay. How many 7s are in 40? How many 7s are in 40? 5? Yes. Because 5 times 7 is 35. When you subtract 35 from 40, you get 5. Right. You can go on and on and on and on and on, but at least we've got 3 digits there, which we can simply round off. Right. So this one will simply be rounded off to 0.29. Okay. Then a quarter, very easy that one is. So a quarter will simply be 4 divided by 1 there. That will give us 0. And 2, that's 8, and that is 2. 0, that will 0.25. So a quarter is actually 0.25. So you can see that this one is 0.25. 27 is 0.29. 5/8 is 0.63. And 2/3 is 0.67. Now that we've converted all of them to the same decimal format, it's very easy for us to compare. They are all 0.0 points, so the zeros in front of the decimals, we're not going to use them to compare them, so because they're all the same. So we go on to the digits after the decimal point. So look at that 6 there, look at that 6 there, look at that number there, look at that number there. So already from these we can tell that, you see, we have got this one and that one there. They are the same. So we have to compare the 7 and the 3. So from this already we can tell that the biggest is 0.67. Right? Then followed by 0.63. Then these two, they all have 2's there. Then we have to compare the next number because these are the same. So we compare the 9 and the 5. So already the smallest there is 2.5 followed by 0.29. So this is how you solve such problems in an exam. Guys, if you find these videos any helpful, please give us a comment in the comment sections, like them, and subscribe to the channel so that you are informed of the new uploads. If there are any suggestions or clues of how these videos can actually be improved, all those comments are welcome, guys, including comments to criticize how the whole videos is being presented is also welcome, because that will help me to actually change a few things here and there to make sure that the lessons that I upload on these videos become more helpful to a lot of students that are actually preparing for the GCSE exam in maths. Okay, on that note, guys, see you in the next video. Okay. Guys, if you find this video helpful, please like, share and subscribe to the channel to help us. Tip donations are also welcome, guys. All you have to do is scan the QR code below. Thank you for watching, guys. Looking forward to see you in another video. Thank you.